Welcome to Megareview Online. Hello everyone! This is Engineer Belinda de la Cruz. What we will be discussing today is all about strength of materials 2, which will cover statically indeterminate members and thin-walled pressure vessels. Okay? So I know na medyo madami sa atin is alanganin or nahihirapan sa subject na to. And don't worry no, kasi nakaka-relate din ako. Nung college, masyadong hindi ko talaga magets kung anong subject na to. So naliwanagan lang ako during my review and I hope kayo din, ngayon pa lang, maliwanagan na kayo. Alright? So let us start no. Let us first tackle statically indeterminate members. So recalling your theory of structures for statically determinate na members, ibig sabihin doon, the available equations of equilibrium are enough na for you to solve all of the reactions and internal forces dun sa member mo. Tama? Pero dito, kay statically indeterminate na members, alright, let us first recall muna what are the equations of equilibrium. I know, grade 1 to sa inyo, no? We have there tatlo. The summation force is horizontal, the force is vertical, and the moment. Okay? And again, dito kay statically indeterminate na members, these equations are not sufficient for you to solve all of the forces dun sa member. Okay? Kaya ginagawa, we have additional equation. Okay? Na kinukuha. And saan natin yan kinukuha? So ito yung mga equations natin na magagamit. Again, una, si equilibrium equation. And sabi natin kanina, hindi siya sapat. Tama? Kaya dito tayo kukuha ngayon sa tinatawag nating compatibility equation. Yes. Okay, ang tanong, ano tong compatibility equation na to? Right? So your compatibility equation are equations that relate the deformations or the geometry of the members upon the application of the load. So yung gagawin mo lang basically is you're going to relate the elastic deformations of your member. So para mas makita mo siya ng maigi is i-exaggerate mo yung deformation na nangyayari doon. So take note lang, yung mga units na gagamitin natin dito, you have here commonly ginagamit are distances, forces, and stresses. Okay? And sa sample problems natin, yung ginamit ata ng mga na units doon are in SI units. Okay? And meron din dito in corresponding English unit. Okay, so for the distance, gamitin natin naka-millimeter. For the force, naka-Newton. And then for the stresses, naka-megapascal. Okay? And yung English, ito naman siya, inches, pounds, and naka-pounds per square inch. Okay? So, naka-megapascal yung stress natin, by the way, kasi if you're going to convert that or to rewrite that, pwede din siyang maging Newton per square millimeter. Tama? So, para uniform sa distance and forces. Alright? So, for this topic, we will be dealing with two types of loading. We have axially loaded members and torsional members. So let us first discuss dito si axially loaded members. So for axially loaded na members, let us say you have here a cylinder, a cylindrical rod, okay, with length L and a cross-sectional area A. And let us say that we are going to apply this force P right here, acting at the center of your member, okay? So, in return, our member will react with the same magnitude but opposite in direction for this member to remain in equilibrium. Tama? So, if the member reacts, ibig sabihin na i-stress itong member natin. Tama? And yung stress na na-experience ng member na to is what we call axial stress. Bakit siya axial stress? Kasi your force P right here is perpendicular to the area na na-stress. Tama? This is perpendicular to the area A. And our axial stress is given by this notation, sigma, which is equal to the force applied over the area. Okay? Your force P right here is pwede mo ding tawaging axial load or axial force. Alright? Ngayon, Ano ba ang mangyayari sa member na to if i-a-apply mo tong force P na to? Compressive force yan, di ba? Specifically, since that is a compressive force, edi our member will compress. Mag-shorten siya. Tama? Up to this length right here. And this length, yung pag-shorten niya is what we call delta or deformation, or specifically axial deformation. And this axial deformation is given by this formula PL over AE. Sikat na sikat to, di ba? I hope sikat din to para sa inyo. Alright? So this axial deformation, okay, you can actually relate this delta by the stress here, the axial stress. Kasi we have here force over area, di ba, dito sa formula na to. And knowing that P over A is axial stress, tama, given by this equation, so axial deformation can be written as the stress times the length over the modulus of elasticity of the material. And here is, by the way, the original length of your member. So tandaan nyo lang yung mga formulas na gagamitin natin dito. Una, we have the equilibrium equation, and then the compatibility equation. Okay? Along with these formulas dito. Okay? Pag alam mo to, wala kang magiging problema sa topic na to. Right? So I think we can now proceed with our first situation. An axial load of 500 kilonewton is to be supported by a 2-meter length steel pipe filled with concrete. The outside diameter of the pipe is 200 millimeters and has a thickness of 10 millimeters. Solve the stresses in the concrete and the steel using the modulus of elasticity for the concrete 24 gigapascal, and then that for the steel is 200 gigapascal. Let us first get the dimensions here at the cross-sectional view. So if you have here an outside diameter of 200 mm, okay, and yung thickness ng steel pipe mo is 10 millimeters, ibig sabihin, this length is your inside diameter. So, i-deduct lang natin ng dalawang thickness. Tama? So, this is 200 minus dalawang 10 mm. That would be your inside diameter, which is 180 millimeters. For the preliminary calculation, let us get the area. Okay? As you can see, you have here two materials. You have the concrete and then the steel. Unahin natin kuha yung part of the concrete, the area of the concrete, which is a circular area. Itong naka-gray na part. Tama? Kasi yung butas ng steel pipe natin is pinunan ng concrete. So, the area would be the area of a circle, pi over 4 times. The diameter here of our concrete is 180 squared. So, yung value na to, paki-store na lang kay E sa calculator nyo. Okay? So, dito ko siya na-store. Nilalayo ko yung area kasi may values ako na nakalaan for variables A and B sa calculator. Okay? Para di ako masyadong malito. Pero kayo, sa part na to, nakadepende na lang kung saan nyo siya iso-store. Right? Next is the area of the steel pipe, which is the hollow part. Itong naka-hatch. Okay, itong naka-pattern. So, that would be pi over 4 times the outside diameter na 200. Okay? Deduct natin sa inner circle, which is 180 yung diameter niya. Tama? And then this area naman is store natin kay F. So here, tingnan natin yung magiging reactions ng ating steel and concrete material when this 500 kilonewton is applied. So hindi naka-state, no, kung anong force itong 500 kilonewton, tension ba yan or compression. So to think na one of the materials dito na gamit is concrete, no? So, si concrete is malakas sa compression. So, most probably, yung pinopoint dito na 500 kilonewton is a compressive force. Okay? So, if this 500 kilonewton compressive force is applied, ano ba yung magiging reaction ng ating concrete and steel? Well, the reaction would be, yes, collinear, but opposite in direction.
Tama? Let us say this is the reaction of the concrete. And then for the steel naman, ito yung ire-react niya. Tama po ba? So these forces are coaxial. So yun na nga, collinear yung mga forces na to. These are all acting at their centroid, dito sa gitna. Okay, so if we're going to use one of the equation na magagamit natin, that is the equilibrium equation, no? We are just going to utilize summation of forces, specifically vertical forces. Tama? Ano bang mangyayari dito? We can say that the force of the concrete plus the force of the steel, that is equals 500 kilonewton. Or gawin nating naka-newton, that is 500,000. Okay? So, gagawin natin dito yung mga units na gagamitin natin would be naka-newton and naka-millimeters. Okay? So, kung stress naman, pwede natin gawin si megapascal kasi megapascal is naka-newton per square millimeters. Okay? Ngayon, you have here your first equation. This is our equation 1. As you can see, you have two unknowns. Tama? So, we are dealing here with statically indeterminate na members. Okay? So, from the three equilibrium equations, summation forces vertical, summation forces horizontal, and summation moment, isa lang yung magagamit natin doon. And yun na nga, that is summation forces vertical. So, saan tayo kukuha ng another equation? Yes, from our compatibility equation. Specifically from their deformation relationship. Tama? So, titingnan natin kung anong mabubuo nating relations mula sa kanilang deformation, no, as you apply the 500 kilonewton na load. Now, since 500 kilonewton na load, sabi na nga natin is a compressive force, ibig sabihin, mag-shorten yung material natin. So, from this initial na position, after 500 kilonewton is applied, no, let us exaggerate yung mangyayaring deformation natin dito para mas makita nating maigi yung relationship nila. Say, yung column mo is napunta dito. Okay? Kasi nga nag-shorten siya. So, this length is our deformation, specifically our axial deformation. Tama? And as you can see, the length of the concrete and then the steel pipe are the same, 2 meters. Tama? And then, the 500 kilonewton load then is applied at the centroid of the element. Tama din. Ibig sabihin, yung relationship ng deformation ng ating concrete and ng ating steel pipe, equal lang. Tama? Yung pagbaba ng steel pipe dito and yung pagbaba ng concrete dito, equal lang yung magnitude na yon. Alright? I hope you're getting that. So, this deformation is an axial deformation. So, we are going to use PL over AE. So, this is for the concrete. This is equals the PL over AE of the steel pipe. So, here, you can cancel out the length of the steel pipe and then the length of the steel kasi nga, equal lang naman yung dalawa. So, this will become the axial force of the concrete. So, nag-cancel man yung L. So, si PC na lang yung nasa numerator. Area of the concrete na store kay E. And then, the modulus of elasticity ng ating concrete is 24,000 megapascal. This is equals the deformation of the steel, which is PS. Length of the steel is na-cancel. Area of the steel naka-store kay F. Modulus of elasticity of the steel is 200,000 megapascal. Okay? So, you can have a relationship of PC in terms kay forces steel. Ilan ba to? That is 0.5116 force of the steel. So, in-express lang natin yung force of the concrete to the force of the steel. And from here, you now have your second equation. No, you have two unknowns and then you already provided two equations. So, masasolve mo na yung problem na to. From equation 1 and equation 2, so using this equation, substitute lang natin yung equation ng PC mula sa 2. That would be 0.5116 of PS plus here PS equals 500,000 Newton. So you can get here the value of the resistance ng steel pipe natin, which is 330,000 779.94 Newton. So from here, you can now also get the force of the concrete using either equation 1 or equation 2. Pero mas madali si equation 2 na. Kasi multiply mo lang ng 0.5116 yung value ng PS. That is 169,220.056 Newton. Pero yung tinatanong dito are the stresses of the concrete and then the steel. So for the stresses, that would be, unahin natin stress of the concrete. This is axial stress. So you just have here force over the area. The actual force over the area perpendicular to that force. So PC mo is this value and then si A sub C is nakastore kay E. Right? So we have here 6.65 megapascal. This is already the answer for number 1. Kulang pa. Tinatanong din si stress ng steel. That is the actual force of the steel over the area of the steel. Area of the steel is nakastore kay F. PS mo is this value. So you will be getting 55.42 megapascal. So this is the answer for number 1. Okay? So I think we can proceed with number 2 kasi madali lang naman, 'di ba? Pinapahanap the deformation of the concrete and then the steel. So pwedeng dumaan ka sa concrete or pwedeng dumaan ka sa steel. Okay? Dapat mag-equal yung dalawa. So gagawin natin, kunin na lang natin both para ma-check din natin if tama ba. Okay? So for the deformation of the concrete, that is PL over AE of the concrete. Okay? As you can see, you have here P over A, that is our axial stress. So pwede natin itong isulat as the axial stress times length over E. Okay? So for the concrete, this would be 6.65. Length of the concrete is 2,000 millimeters. Elasticity of the concrete is 24,000 megapascal. And this is 0.55 millimeters. Right? So, pwede ka na mag-stop dito, pero if gusto mong manigurado, again, you calculate yung deformation of the steel, which is, stress ng steel is 55.42, length is still 2,000, modulus of elasticity ng steel is 200,000. And from there, you can confirm that still the deformation is 0.55 millimeters. Okay, those are the answers. Pwede rin in getting the values PS and PC, you can use the equation mode na nasa calculator nyo. So you just have to generate two equations. Okay, yun na nga, yung isa sa equation natin is this one. And then, yung second equation natin would be this one. Tama? So, gagawin mo lang is i-rewrite mo yung equation na to para maging same ng mga variables dito. So, mauna si PC, and then masunod si PS. And then, balibag mo sa kabila yung constant. So, for this equation, pwede mong gawin, that would be PC. Tama? So, transpose PS sa kabila, that would be negative 0.5116 of PS. So, wala mang constant, equate mo yan to 0. So, yung input mo sa calculator, punta kang mode 5.1. So, that would be 1, 1, and then 500,000. You have there for the second equation, 1, and then negative 0.5116, and then 0. So, you can see, no, yung una mong makukuha dito is the value PC, kasi yan man yung nauna dito sa equation mo na set. As you can see, medyo may discrepancy, diba? Kasi hindi mo kasi tinor yung value na to. Tama? Pero malapit lang siya. Then, yung sunod mong makukuha is si PS naman. Okay? And then, same yung flow ng solution for the stresses and then the deformation. The rigid bar of negligible weight is pinned at O and attached to two vertical rods, assuming that the rods were initially stress-free. Number 3, what is the largest load P that can be applied without exceeding stresses of 125 megapascal in the steel rod and 60 megapascal in the brass rod. So, here, when these rods are stress-free, ibig sabihin wala pa tong load P mo na to dito. Tama? Doon lang siya na-stress nung naka-attach na tong load P na to. So, using the equilibrium equation para makakuha tayo ng first equation to solve this problem, paano ba natin to gagawin? As you can see, no, this load P is a downward na force. Tama? So, yung resistance ng steel and brass rod natin, makikita lang natin yan if ikakat natin yung mga rods na yan. Okay, such that yung force ng steel, that is specifically a tensile force, sa brass rod din is a tensile force. Tama? Tawagin natin yung force ng steel natin as PS, and then sa force naman ng brass natin is PB. Okay? Using the equilibrium equation, we can take moment dun sa point O. So, let us assume that counterclockwise rotation is a positive rotation. So, with respect sa moment sa O, sino ba dyan yung nakaka-produce ng counterclockwise rotation? Yes, itong load P. Tama? Na may moment arm 2. So, that would be 2P. And then, yung rotation due to PS and PB are both clockwise, so that would be negative. Tama? So, this is minus 1.5 PS minus moment arm ng PB is 3. So, that would be minus 3 PB. This is equal to 0 for equilibrium. So, tawagin natin to as our equation 1. As you can see, you have three unknowns. The P, the value of PS, and then the value of PB. Ma'am, dalawa lang yung nagamit natin kanina, di ba? The equilibrium equation and then the compatibility equation using deformation equation. So, wag magalala kasi actually you have there another given sa problem. So, mamaya, malalaman natin. Punta muna tayo sa deformation equation natin. Nung na-apply na yung load natin, bale yung bar natin is mahihila dito pababa. Tama? So, since the bar is rigid, no? After mong hinila yan, the bar will still remain straight. Pero naka-incline na siya dahil sa load na to. Bali mangyayari, magiging ganito na yung bar natin because of this load P. Yung pag-angat ng rod dito causes deformation dito sa brass rod natin. Bali nahila pataas yung brass rod natin. And this deformation is actually your axial deformation dun sa brass rod mo. Tama? Dito naman banda, di nahila din dito yung steel rod mo. And then yung length na to, this is already the deformation, the axial deformation of your steel rod. Okay, andyan ka kukuha ng relationship sa mga deformation na to. Okay, paano? Through ratio and proportion. Tama. Looking at this triangle here, diba, may right triangle ka dyan, meron kang dalawang similar right triangle. Ano bang pwede mong sabihin dyan? Unahin natin si deformation sa steel rod over its distance mula dun sa pin is 1.5. This is equals, ano ba yung corresponding side ng delta S? That is delta B, the deformation of the brass rod. Okay? Corresponding distance of 1.5 is 3. Tama? So, ibig sabihin, the deformation of the steel rod is kalahati ng deformation ng brass rod. We said that this is axial deformation. Ma'am, paano yan naging axial deformation? Hindi ko masyadong ma-imagine. Let's say, i-cut ulit natin yung ating rod dito. Consider natin yung part na to. Let's say, ito yung ating steel rod, di ba? Ito yung cut section natin. No, natitense man yung steel rod natin, ibig sabihin, pa-pull yung force. Tama? This is our PS. As you can see, this is axial load kasi yung force PS natin is perpendicular, tama, sa ating cross-sectional area, this one, itong circular area na to. Okay, kaya yung gagamitan natin ditong deformation is again, axial deformation, which is PL over AE. Right? So this is PL over AE of our steel. This is equals 1/2 the PL over AE of our brass rod. So for this value, this L over AE of the steel rod, pakistore na lang yan kay A. Okay, so that would be the length of the steel is 1/500 millimeters. Tama, area is 800 and then the elasticity is 200 gigapascal. So, store nyo yan kay A, bali mangyayari this will become yung value na nakastore kay A times the force of the steel. Okay? This is equals, yung value naman na to, that is 0.5 times L over AE, store mo naman yan kay B. So that would be 0.5 times length of the brass is 2,000 millimeters, area of the brass 250, modulus of elasticity is 83,000 megapascal. So this will become yung nakastore kay B times PB. Now we have our second equation. No, kulang pa tayo ng pangatlo kasi tatlo yung unknown, P, PS, and then si PB. Take note na may binigay sa problem, no? Without exceeding stresses of 125 in the steel rod, 60 in the brass rod. Ngayon, isulat natin yung mga allowable stresses na yan. Kasi dito tayo kukuha ng third equation. Right? So, mula dyan, our allowable stress daw dito sa steel natin is only 125 megapascal. Then, the allowable stress of the brass is 60 megapascal. Okay? Ngayon, wag mong gawin no na i-utilize mo lahat ng allowable stress. Okay? Ano ba yung ibig kong sabihin? 'Di ba dito sa allowable stress na to na 125 megapascal for the steel, pwede mong kunin dito yung axial force of the steel rod. Tama? Kasi may area ka man ng steel, so eventually, makukuha mo to. And then dito din, pwede mo din makuha dito si PB. E di may nakuha ka dito ang allowable force of the steel. Dito din, may nakuha kang allowable force of the brass. Then yan yung gagamitin mo dito mula sa equation 1 para makuha si P. Mali po yun. Isa lang yung material na i-maximize natin para ma-follow yung ating deformation relationship. Pag kasi ginamit natin simultaneously ng sabay, yung allowable forces ng steel and brass, hindi na magiging ganito yung relationship ng deformation ng steel and brass natin. So, ano bang sinasabi ko? Unahin nating utilize itong allowable stress ng steel. So, pag ginamit natin itong 125 megapascal na allowable stress ng steel, ibig sabihin nun, minamaximize natin yung capacity ng steel. Pinapauna natin siyang mag-fail. Okay? So, with that, kunin natin yung corresponding allowable force of the steel. Meron man tayong stress, so pwede natin kunin si force by force over area. Kasi actual stress lang naman to. Okay? So, this is force of the steel allowable over the area of the steel. So, this is 125. Area of the steel is 800. So, you can get the maximum, no? Na allowed force for steel before siya mag-fail. And that is 100,000 Newton. So, kunin natin this time yung corresponding value of the force dun sa brass if minamaximize natin si steel. Tama? And dapat yung makuha nating stress dun should not exceed the allowable stress na given sa brass which is 60 megapascal. So, isolve muna natin. Paano ba natin isosolve si force ng brass given naman tayo ng allowable force ng steel? E di, we can utilize this second equation. Tama? We have a relationship between the force of the steel and the force ng brass. So, naka-assume naman tayo, di ba, na ipapa-fail natin una yung steel rod natin. So, meron tayong force PS na dito. So, from equation 2, that would be A. Then, PS mo is already 100,000. This is equals yung nakastore kay B times PB. From here, you can get the value of PB, which is 19,453.125 Newton. With this force, kunin natin yung axial stress ng brass natin. And i-check natin if nag-exceed ba yan or hindi sa allowable stress ng brass. So, this is force of the brass over the area of the brass. Okay? Sa area of the brass, this is 250 square millimeters. Then, PB mo is itong nakuha mo dito. Ilan ba to? This is 77.81 megapascal. So, anong nangyari? Yung stress ng brass rod natin nag-exceed sa allowable stress ng ating brass rod, which is 60 megapascal. Ano bang ibig sabihin? Hindi nag-fail yung brass rod natin. So, wag mo tong gamitin kasi may isang element na nag-fail. So, dapat yung makuha mo na value should not exceed the allowable value. So, if nag-fail dito, let us try naman, using the allowable stress of the brass rod, which is 60 megapascal. So, if gagawin mo to, ibig lang sabihin nito is ipapa-fail natin una si brass rod. So, siya yung mauunang ma-achieve yung kanyang allowable stress. So, here, pwede natin kunin si allowable force of the brass rod, that is stress is equals allowable force of brass over the area of the brass. Area of the brass, that is 250 square millimeters. So you can get here the allowable force of the brass rod, which is 15,000 Newton. So hanggang dito lang dapat yung i-apply mong load sa brass rod para hindi siya mag-fail. Okay? With this value, kunin natin yung corresponding force of the steel using again equation 2. So that would be yung nakastore kay A times yung hinahanap natin na PS. This is equals yung nakastore kay B times the PB. Okay, which is ito ng 15,000 kasi nga pinapa-fail natin una si brass rod. Right? So with this, you can get the value PS, which is 77,108.43 Newton. So from here, makikita mo na pasok to. Kasi yung nakuha mo kanina, 'di ba, yung allowable na force na pwede mong i-apply sa steel is up to 100,000 Newton lang. No? This one is less than 100,000. So hindi to mag-fail. Pero i-calculate na lang din natin yung corresponding stress nito, which is force of the steel over the area of the steel. Area of the steel, that is 800 square millimeters. So this stress is equals 96.39 megapascal. As you can see, this is less than the allowable stress of the steel na 125 megapascal. So okay to, pasok to. Tama, kasi walang nag-fail. So yung gagamitin mong values, kasi tumama ka naman, wala nang nag-fail. Yung force of the brass rod is already itong 15,000 Newton. And then yung force ng ating steel rod na gagamitin is this 77,108.43. By the way, lagyan lang natin to ng remarks. This is okay. While yung nauna naman, this is not okay kasi nag-fail. So from there, you can get the value of P using equation 1. So mula dito sa ating equation 1, so this is 2P minus 1.5. PS mo is 77,108.43 minus 3 PB mo is 15,000. Okay? This is equal 0. So you can get the value of P, which is 80,331 Newton, or that is 80.33 kilonewton. So this is already the answer for number 3. And then for the number 4, what are the stresses acting on the steel and brass rod? Actually, nasolve mo na yan. Tama? Yung stress na nag-a-act dun sa steel and brass rod should be the stresses na hindi nag-exceed sa allowable stress. So that is for the brass rod, that is 60 megapascal. For the steel rod, that is, si 96.39 megapascal. A round steel rod is in between two vertical round brass rods. The level of the upper end of the steel rod is 0.06 millimeters below that of the plate. Use the modulus of elasticity 200 gigapascal for the steel. For the brass is 105 gigapascal. What is the maximum value of P so that the central bar is not stressed? Before tayo pumunta sa number 5, tingnan muna natin yung top view or yung cross-section view ng ating structure. Okay, looking at the top view, you have here your steel rod which has a diameter 35 millimeters. Tama? And then, yung dalawang brass rod natin is in this orientation. Kasi nga sabi sa problem, no? A round steel rod is in between two vertical round brass rod. So, this is different from the other item siguro na na-meet nyo last time. 'Di ba? Kasi yung item na yon is may word na coaxial. So, from the word coaxial, from the other item, okay, nangyari doon, yung force ng brass, ng force ng steel, and yung force P dito na na-apply are collinear. Again, because of the word coaxial. And then, yung cross-sectional view, okay, yung brass rod, doon sa item na yon is pinapalibutan yung steel rod natin. Kumbaga, hollow yung brass rod natin sa item na yon. Well, dito, hindi, because of this statement. So, mag-ingat lang. Now, looking at the cross-section view, the diameter, kunin natin yung diameter of the brass rod. So, this one is 50 and 60. So, may 10 na natira for this part. Kalahati yung sa kanya, 5. And then, dito naman is 5. So, yung diameter ng ating brass rod, this one, itong dalawang to is our brass rod, and then this one is our plate, kung saan mo in-apply itong force P. Tama? So, kunin natin yung areas ng ating steel rod and ng brass rod natin. For the brass rod, that is cross-sectional area is a circle, pi over 4 times 5 squared. Store natin to kay E. For the steel rod, that is pi over 4 times 35 squared, store nyo naman yan kay F. Okay? Now, balik tayo sa tanong, what is the maximum value of P such that hindi na stress yung central bar natin? So, gamitin natin yung dalawang equation natin, equilibrium equation and the compatibility equation. Unahin natin dito si equilibrium equation natin. So, kailan ba hindi na stress yung ating central steel bar? Kapag wala siyang binibigay na reaction dun dito sa in-apply mong load P. Tama? So, with that, edi yung magre-resist lang dito is yung dalawang brass rod natin. Tama? Let us name this one as P sub B. Right? Dalawa yan kasi based on our cross-section view, you have here two vertical rods. So, wala po ditong ire-react yung force ng steel. So, by using the equations of equilibrium, pwede natin gamitin si summation forces, vertical equals 0. Tama? From here, pwede nating sabihin that the force P is equals dalawang force of the brass rod. So, yung force mo dito sa brass na to is just equal sa force dito. Kasi yung force P natin na in-apply is same lang naman yung distance niya dito patungo sa rod na to, tama? And then same lang din dito sa rod na to. Tama po ba? So, equal lang yung forces na yan. And isa pa, yung dimension ng brass natin is parehas lang. And then yung material din. Tama? So, PB here is just equals PB here. So, force P mo is equals 2PB for the equilibrium equation. Okay? So, hindi mo man magagamit yung other equilibrium equation mo, ito lang. So, you can proceed with the next equation, which is the compatibility equation, or through their deformation relationship. Ano ba yung final positioning ng plate natin such that hindi pa rin na-stress yung steel bar natin dito? To get the maximum value of P, no? Tapos hindi pa rin na-stress yung steel bar natin, yung magiging displacement ng ating plate should be equals 0.06 millimeters. Tama? Kumbaga, ito yung magiging final positioning ng plate natin as you apply the maximum value of P. I hope you're getting that. So, in this case, yung nangyari dito, the plate, this plate right here just touches the top of your steel bar. Pero although nagtatouch yan, just touching man, ibig sabihin, wala pa rin i-react yung steel rod natin. Kumbaga, that is the critical positioning. No? Konting increase lang ng load P, magkakaroon ka na ng reaction dun sa steel rod. So if ito yung ating 0.06 millimeters na pagbaba ng plate natin, di ibig sabihin, yan din yung magiging deformation ng dalawang brass rod na to. Tama? Mag-shorten or mako-compress yung brass rod natin up to 0.06 millimeters. No? In this case, since hindi man na-stress yung steel rod natin, ibig sabihin, wala ding deformation na nangyayari doon sa steel rod natin. Yung dalawang brass rod lang yung nagde-deform. So with this, pwede nating sabihin by their deformation relationship, the stress of the brass rod, ng dalawang brass rod na yan, is equals 0.06 millimeters. So since yung force P natin is applied sa gitna, okay, at the center of the steel rod, di ibig sabihin, yung plate na to will remain horizontal as the compressive force P is applied. Kaya equal lang yung deformation sa brass na to, tas dito sa deformation ng other side of the brass. This is axial deformation again. Tama? Kasi if we're going to cut, tas titingnan mo sa top view, this is your brass rod. Tama? So you have here your compressive force dito sa brass natin, which is acting perpendicular to the cross-sectional area. Tama? So we have here PL over AE pa rin, axial deformation. This is for the brass rod. Okay, so this is 0.06 is equals force of the brass rod. The length of the brass is 200 millimeters. Area of the brass rod is nakastore kay E. Modulus of elasticity of the brass rod is 105,000 megapascal. So you can get here the force of the brass rod, which is 618.502 Newton. So from here, edi pwede mo nang kunin yung force or the maximum value of P such that hindi na-stress yung steel rod natin. Using this equation na nakuha natin from equilibrium equation, equation 1. So from equation 1, edi P natin is twice the force dun sa brass rod natin. And this is equals 1,237.002. Okay? So this is the answer for number 5. Number 6, if this maximum load is doubled, what will be the stresses in the steel and the brass rod? So for number 6, tawagin natin yung bagong load P natin as P prime. Okay? So yung bagong load na to, yung value niyan would be twice yung nakuha mo ditong maximum value of P such that hindi na stress yung steel mo. So this would be 2,474.004 Newton. So bali yan yung bagong load na i-a-apply mo sa plate mo. Tama? So pag yan yung load na in-apply mo sa plate, edi ibig sabihin, yung magiging displacement ng plate mo will exceed 0.06 millimeters. Let's say hanggang dito, no? Nag-displace or yung positioning ng end ng plate mo. Tama? This length is our total displacement of the plate. Now, as you can see, nagde-deform na rin yung steel rod natin. Tama? Kasi nag-exceed man ng 0.06 yung deformation. E di ibig sabihin, nag-deform man siya, may reaction nang nangyayari doon sa steel rod natin. So if this is the final positioning of our plate, tama? E di you have here 3 reactions. Dalawa, for the brass rod, may i-react din yan, tawagin ulit natin PB. And then, si steel rod din, may reaction na yan. And using the equations of equilibrium, pwede nating sabihin that our force P prime, which is equals 2,474.004, is nilalabanan ng dalawang brass rod and isang steel rod. So, 2 unknowns, so we need again 2 equations. Kuha ulit tayo sa ating compatibility equation from their deformation relationship. Now, as you can see, nag-exceed ng 0.06 again yung ating displacement ng plate. Ibig sabihin, yung total deformation ng brush rod natin is this length din. Tama? Yung displacement ng ating plate is also the deformation of our brush rod. And then this deformation, yan, is the deformation of the steel rod. Tama? Kasi again, sabi natin na stress na yung steel rod natin. From there, we can generate the relationship of the deformation of the brush and the steel rod. Looking at this figure, we can say that the deformation of the brush rod is 0.06 plus the deformation of the steel rod. We are again dealing here with axial deformation. So we have here PL over AE equals 0.06 plus the PL over AE of the steel rod. So this equation, L over AE of the brush rod, store nyo yan kay A. Okay, so length of the brush rod is 200 millimeters. Area is nakastore kay E. Modulus of elasticity is 105 gigapascal. So this one would be yung nakastore kay A na value times PB. Right? This is equals 0.06 plus yung L over AE naman ng ating steel rod is store nyo naman kay B. Length of the steel rod, that is 250 millimeters. Ma'am, hindi po yan 250 kasi may offset po na 0.06 dito. Yes, that is correct. Pero sobrang liit na ng 0.06 millimeters. So, you can consider the length of the steel as 250 millimeters na diretso. Okay? So, that would be 250 over the area of the steel nakastore kay F. Modulus of elasticity of the steel is 200 gigapascal. That value, store mo yan kay B times the force of the steel rod. Okay, ngayon, rearranging our equations. This is our equation 1, and this would be our equation 2. Our equation 1 is 2PB plus PS equals 2,474.004. Equation 2 natin would be, unahin natin since naka-PB to, so unahin din natin si PB. Then, balibag natin si PS, so that would be negative B times PS equals 0.06. And then, you can go to equation mode of your calculator. That is mode 5.1 for 2 unknowns. So, yung unang valueng makukuha mo is yung PB, that is 633.774, tama, Newton. And then, PS, yan yung huli mong makukuha kasi yan yung huli dito. That is 1,206.456 Newton. Tinatanong, di ba, are the stresses? So, force over area ulit. Okay, so for the stress of the brass, that is 633.774. Area of the brass is nakastore kay E. That is 32.28 megapascal. Okay, for the steel naman, force ng steel is this one. Area of the steel nakastore kay F. This is 1.25 megapascal. Okay, so these are the answers for number 6. As you can see, malaki talaga yung stress na mafe-feel ng brush rod natin kasi sobrang liit ng resisting area ng brush natin. 5 millimeters lang. As compared dito sa steel rod natin, konti lang yung stress na nafe-feel niya kasi malaki yung resisting area natin. So that would be the answers.